mesh analysis. Okay. Mesh analysis is nothing but it is one of the method in KVL. These are Kirchhoff's voltage and elastics, where we solve the problems using branch currents method. Right? Now this is mesh analysis, where mesh is nothing but this particular loop is known to be mesh. A loop which does not contain another loop inside is called mesh. Understand? So this is a loop which does not contain any other loop inside. So this is one mesh. Okay? Whereas this is a loop which does not contain any other loop inside. So this is another mesh. Okay? Whereas this entire thing cannot be a mesh because there is one loop inside. That is a loop. Okay? So what is a mesh? A loop which does not contain any other loop inside is called mesh. Okay? In branch current method, what did we do? We had currents for each branches and just multiplying resistor with that branch current, we found out some current. Right? Here, the mesh current method is nothing but, see, this analysis is also known as mesh current method, which is nothing but for each mesh, I am going to assign one current value. For each mesh, I am going to assign one current value. Suppose if I take this is mesh, I can assign one current value as I1. This is another mesh, I can assign one current value as I2. Okay, right? So in mesh current method, first step is assign the currents. For each mesh, each current. How many meshes do I have? That many number of currents I will have. Understand? Suppose you have one more mesh, you will be having I3 also. So depends upon number of meshes, number of currents will be there. That is clear? The first step is what? Assigning currents for each mesh. Okay? And second one is the current should be assigned only in clockwise direction. In branch current method, if this is positive, we will be assigning like this. Okay, from positive towards inside the circuit, we will be assigning, right? So here that is not the case. We need to assign what? For each, it is only in clockwise direction. So how many meshes you have? You assign the currents only in clockwise direction. That is point number 2. Okay, and then after assigning the current for each mesh, I need to write KVL for each mesh. For each mesh, I need to write what? KVL. So KVL is applied in mesh analysis in order to find out what? Unknown current I1 and I2. Okay, so mesh analysis is used to find out what? Unknown current by using KVL. You know what is KVL? Kirchhoff's voltage law. The sum of the If I assume this current also in anti-clockwise direction, then at that case I1 also flowing inside, I2 also flowing inside. Right? So what will happen? So at that case, both flows inside. Now current through 10 ohms resistor is what? I1 plus I2 because 10 ohms is present in the center. When I1 also flowing like this, I2 also flowing like this. So the current through 10 ohms resistor is what? I1 plus I2. Now I1 is flowing inside, I2 is flowing out. Right? Like this. I2 is flowing like this. Then what is the current through 10 ohms resistor? I1 minus I2. It may be either I1 minus I2 or I2 minus I1. Because the current cannot be a negative number. When you apply some voltage, there will be some current. Always there will be some current when I apply some voltage. So current cannot be in a negative number. Current can always is what? Positive number. If I1 is greater, it is I1 minus I2. If I2 is greater, it is I2 minus I1 because it must be a positive number. Okay, but the current through 10 ohm resistor is what? Difference of these two currents. Up to that clear? So we write KVL for mesh 1. So KVL for mesh 1 is coming from here. This what? Minus 30 into what is the current flowing through that resistor? What is the current flowing through that resistor? I1. So minus 30 into I1. Then here coming here minus 10 into what is the current flowing through that resistor? I1 minus I2. Then coming here we are actually putting leading sign. Okay. Yes. So minus 30 into I1 minus 10 into I1 minus I2 because it is present in the center. Then what is the leading sign here? Plus 120. Plus 120 is equal to 0. Since it is a voltage value, we are directly writing it. Alright? So I need to solve it. Minus 30 into I1 minus 10 into I1 plus 10 into I2 is equal to minus 120. So what is that? Minus 40 I1 plus 10 I2 is equal to minus 120. So what I can do is I can divide it by 10 and multiply it by minus. If I do both, it will become 4 into I1 minus I2 divided by 10 is 1. Okay. Then is equal to 12. So this is your equation number 1. Clear? This equation is clear. If this equation is wrong, what you get here will be wrong only. Then everything is wrong. The right and I2 values will be wrong. You need to write this equation and check it out once again and then proceed the problem. Okay, right? So we'll write for mesh 2. Now tell me the equation for mesh 2. So we'll take all resistors, we'll take minus 60 into what is the current through that resistor? I2. Okay, ma? That is in first loop. So I1. 30 in first loop I1. 50 is in what? Second loop, so it is what? I2. So minus 50 into I2. Minus 60. Minus 10 into what? So we'll write whatever it is. Resistance will write minus. Okay? Minus 10 into now I2 minus I1. Very good. Because if I write for first move, I assume first current is greater. So I am writing I1 minus I2. If I write for second loop, I am assuming second current is greater because second current is dominating current here. Here first current is dominating current, here second current is dominating current. So I should write what? I2 minus I1 is equal to 0. Okay? So that is very, very important. If you change it, again the answer will be wrong. Okay? So this is I1 minus I2, this is I2 minus I1. So this one, minus 50 into I2, minus 10 into I2, plus 10 into I1 is equal to 6, which is equal to plus 60 is again 6. That is equation number 2. Okay. Since I have only 2 equations, I can straight away use quantitative method just to solve it, cutting method to solve it. Yeah, otherwise you can go with grammar school if I have more than 2. Either way you can proceed with grammar school. Okay, do it and let me know the values of I1 and I2. Do it and let me know the values of I1 and I2 fast. Copy it down first. This is KVL for mesh 2. That is for mesh 1 and this is for mesh 2. See, by applying Cramer's rule, is this clear? This is I1 value, this is I2 value, right? When I solve it, del is minus 23. Now I am going to solve del I1, so replace the first row and put 12, 6, the first column replacement. Now multiply it, so you will get minus 66. So in order to get I1, it is what del I2 we have applied del. So it is 2.86. Suppose if I want I2, that is what? Del I2 divided by del. So del I2 how to find out? 4, 1, 12. 24 minus 12. So del I2 is 12. Okay. So I2 is del I2 by del, which is equal to minus 23 divided by 12. So I2 is minus 1.91 now. 1 minus 1.91 here. Okay. So I1 is 2.86, I2 is minus 1.91 here. So seeing that, obviously by seeing that I know I1 will be greater than I2 because I1 has a higher voltage 1/2. I2 has only 60 volt. Okay. Actually the current direction must be in this direction only because the current is flowing like this one. 60 volt if I apply there, from positive the current should flow like this. Yes, we have assumed an opposite direction. That is why you are getting minus for I2. We will be getting plus only for I1 because we are assumed in the same direction, correct direction. So just by seeing the numbers, you can find out whether we have done properly or not. You understand? You understand why I am getting negative number for I2? I2 must be flow in this direction. We are assumed in opposite direction, that is why we get minus. But value will be same, only sign will be different. You cannot write I2 is equal to like this. You should write I2 is equal to plus 1.91. So if you get minus answer, you should take the diagram and redraw the diagram. Diagram you should redraw, not redraw. You should put current in this direction because the assumed direction is wrong. Now you write I2 is equal to plus 1.91 ampere. After redrawing the direction, you should change it to plus. Understand? Why it is getting in minus? Understand why you are getting in minus? Because current should flow like this from plus 2 like this. We are in an opposite direction, so it is minus. So just by seeing this, you can verify whether your calculation is right or wrong. Okay? So you will be getting exact calculations. Suppose they will ask you find the unknown currents, then you need to find out I1 and I2. They will ask you find the current through 30 ohms resistor. Then it is necessary to find only I1 because current through 30 ohms resistor is what? I1. They ask you find current through 50 ohms resistor. I2. They will ask you find the current through 10 ohms resistor. Mostly they will ask only the middle resistor. Now what is the current through 10 ohms resistor? It may be either I1 minus I2 or I2 minus I1. So our values are, this is 1 ohms resistor present between I1 and I2. Okay. So the current through 1 ohms resistor is what? I1 is flowing like this, I1 is going out, I2 is going out. So it is what? I1 minus I2. Okay. Then, so when I come like this, I have 1 ohms resistor, then I have what? 6 volt source. 6 volt voltage source. So voltage value is to be entered as such, right? So leading sign is minus 6. Voltage value no into current, just voltage value. Then minus 2 into I1 minus I3. Then plus 7 is equal to 0. Plus 7 is equal to 0. Just for voltage sources you see minus plus for mesh analysis. For all resistors minus. Okay, right? Yes. So you understand minus 1 into I1 minus I2. Leading sign is minus 6. So minus 6. Here what? 2 into I1 minus I3. What is the leading sign? Plus 7. So plus 7. Leading sign this is minus. Leading sign resistance are plus. Don't confuse. Take leading sign. Okay. So if I solve it, this minus I1 minus I2 minus 2I1 plus 2I3. 7 minus 6 is equal to minus 1. Right? So I1 is minus 3I1 plus I2 plus 2I3 is equal to minus 1. If I multiply by minus, it becomes 3I1 minus I2 minus 2I3 is equal to 1. Okay, so it becomes minus I1 plus I2 minus 6 minus 2I1 plus 2 into I3. 6, 7 minus 6 is plus 1. If you take plus 10, it becomes minus 1. Okay, so is that clear? Okay, great. So we can write it. First you tell me KVL for mesh 2. Mesh 2 KVL, tell me. See, how many number of components you have, that many number of values should enter here. That you check it out. Okay, so I have 2 voltage source, 2 resistors. So 2 resistor values, 2 voltage source values should be entered. If you have too many resistors, you will miss out. Check that. Okay, now in the second group I have only 3 resistors, no voltage at all. So 3 elements should come. All 3 are what? Only resistors, no voltage sources. Right? So for second unit is what? See, 2 belongs to only to I2. 2 is not present between any two currents. So it is minus 2 into I2. Minus 3 into I2 minus I3. Minus 1 into I2 minus I1 is equal to 0. Okay. So 2 belongs only to I2. So minus 2 into I2. 3 belongs to I2 and I3. 1 belongs to I2 and I1. So equal to 0. Okay. Solve it and get the equation with this and take it as 2. Now apply mesh